Dear viewers, welcome back. Problem 11-31. So statement is determine the variation in the depth W as a function of x for the cantilevered beam that support a concentrated force P at its end so that it has a maximum bending stress sigma allowable throughout its length. The beam has a constant thickness T. So you can see this is the beam that has a constant thickness T, and one end of this beam is fixed, so it is a cantilever beam, and there is a point load at the end. So you can see this width is changing along the length x. Clear? So what we have to find, we have to find this W in term of x. W is a function of x. So let's start with the solution. The first step is that again we will write that we know that maximum bending stress is equal to m into c divided by I. So that is, again, if you further simplify it, it will be equal to m I divided by c, and this I divided by c is equal to s, which is section modulus. So we will find this section modulus S is equal to I divided by C. We do not have I, we do not have C. And what if you cut this beam along this length X? Clear? And you draw the free body diagram. So if you draw the frontal view, it will be like this. There will be a concentrated load P. This distance is X. So definitely if you cut it, there will be a shear force V and there will be external moment M. So you can find this shear force by using sum of all forces along y direction must be equal to 0 and taking the upward force is positive. So minus P plus V is equal to 0. So it means this shear force will be equal to P. Now what about bending moment? So if this is 0.1, so we will find this sum of all moment about 0.1 is equal to 0 and taking the counterclockwise moment as positive. So first moment about 0.1 is P into perpendicular distance x. This is counterclockwise, so it will be positive. And the second moment will be this one, which is counterclockwise. This will be also positive, so their sum must be equal to 0. So I will write P into x plus m is equal to 0. So it means that moment is equal to minus P into x. So what does minus P into x means? That our assumption is wrong. This should be in clockwise direction. So we will see that this should be in clockwise direction. Okay. Okay. So now we know that S is equal to I divided by T. If you look at the cross section, so cross section will be like this one. So here this width is W and this is the thickness T. Clear? So if you take the neutral axis, so C will be equal to T divided by 2. And I will be equal to 1 over 12 BH cube. So 1 over 12, B is W and H is T cube. Clear? And C is T divided by 2. So you can just put over here. So S is equal to 1 over 12 WT cube divided by T by 2. So when you simplify this, so you will get section modulus will be equal to WT square over 6. Now we know that allowable bending stress or maximum bending stress is equal to moment, clear, divided by section modulus. So we are taking the mod. So P into X divided by S is WT square over 6. So you will get allowable stress comes out to be P into X divided by WT square over 6. Let this is your equation number 1. Now what if we want to take X is equal to L? X is equal to L. So here you can see that this width will become equal to W naught over 2, W naught over 2. So it will be equal to W naught. So put x is equal to L and W is equal to W naught. At x is equal to L, W will become W naught in equation 1. So when you put it, you will get sigma allowable is equal to P into L divided by W naught T square over 6. Let this is equation 2. Both equation 1 and 2 are allowable stress. Sigma allowable is equal to this term and sigma allowable equal to this term. So equate, both are same. So equate 1 and 2. You will get P into X divided by WT square over 6 is equal to P into L divided by W naught T square over 6. This P will cut with P, T square will cut with T, and 6 will cut with 6. So we will left with X over W is equal to L over W naught. We are interested to find W in term of X. So W is equal to W naught into X over L. So you can see that this W is a function of X and this width is equal to W naught into X over L. So what if you find the width at any point? So what we will do at any section? So it will be equal to W naught into X over L. So if you know X over which you find this width, so you just put it X, you will have total length and W naught. So you will get this W at any X length. And this was all about problem 11-31. It was a very easy problem. I hope you have enjoyed it. Those who are new to my channel, then I will request them to subscribe and hit the bell icon so that you can get notification about latest video. If you have any question, you can ask me in comment section. Thank you.